The moment of a force is a measure of its tendency to cause a body to rotate about a specific point or axis. This rotation effect is called the moment of the force about that point. The moment of a force, denoted by m, about point O, is defined as the cross product of the position vector r and the force vector F. Here, r is directed from point O to any point on the line of action of the force. This cross product yields a vector quantity representing the rotational effect of the force about point O. In a two-dimensional scenario, if a force acts on a body as shown, it can be substituted by its components, Fx and Fy, as illustrated in the figure below. If the coordinate of any point on the line action of the force is denoted by x, y, then the moment of a force, denoted by m, about point O, is definite as the product of Fy and x minus the product of Fx and I. Force about point A can be determined by projecting a perpendicular distance d from point A to the line of action of the force. Thus, the moment is equal to F multiplied by d. Alternatively, we can resolve the force F into its components Fx and Fy as illustrated below. Then, the moment about A simplifies to Fy times AB. Determining the moment of the force F about point O can be approached in two ways. The first method involves projecting a perpendicular line from point O to the line of action of the force. Yet the calculation of the perpendicular distance d1 can be complex. Alternatively, we can resolve the force F into its components Fx and Fy as depicted below. Subsequently, the moment about A simplifies to Fy times AB minus Fx times OA. In this example, a force is applied on the beam as shown. Then, the angle alpha that produces maximum moment about A, where alpha between 0 and 180. The maximum moment of the force F. When resolving force F into components Fx and Fy along the x and y axes, respectively, if Fx passes through point A, its moment is 0. Then, the moment about A equals F sin alpha multiplied by AB. It's evident that the moment is maximum when sin alpha equals 1 or alpha equals 90 degrees. The same result can be obtained by rotating the force F about the point B and observing the value of ma. It reaches its maximum value when F is perpendicular to AB. O is the maximum moment of the force F about point O can be understood with the assistance of the line OB and its perpendicular. We can observe its rotation anti-clockwise around point B. Consequently, the moment about O increases until it reaches 0 when the force passes through point O, and it further increases until it reaches its maximum value when the force is perpendicular to OB. The angle alpha can be determined from the geometry of the figure. The angle alpha equals beta plus 90 degrees, where beta can be found using the tangent function as tan. Beta equals OB over AB. The maximum magnitude of the moment equals F times OB.